Hi everyone! This is the first video in a series of videos on how to simplify rational expressions. By the end of the video, you'll be able to simplify rational expressions, including different operations such as multiplication, division, addition, and subtraction. So first, what is a rational expression again? Remember, a rational function is essentially a fraction with variables. So it's got a polynomial in the numerator and denominator, as you see on the screen here. An expression is like an equation without an equal sign. It's just a mathematical statement. So that's what we're going to be working through in these videos. We're going to start with simplifying, and I think the easiest way to learn how to simplify a rational expression is by reviewing how to simplify a regular fraction with just numbers. And that's what you have in this column here, is a regular fraction, 68 over 124. How do you simplify this to put it in its simplest form? That's our first objective. Okay. A reminder is written off to the left here when I said, in order to simplify a fraction, you are going to find the greatest common factor between the numerator and denominator. So a common factor is a number that will divide evenly into both of these. And you're going to look at what 68 and 124 have in common. And probably the first thing I think most students would say is that both of these numbers are divisible by 2. All right, we can definitely divide them both by 2 because they both end in an even number. Now, I'm going to do that, and before I actually divide it out, I'm going to rewrite it as a product. So I know 68 divided by 2 would be 34, so that means 68, written equivalently, is 34 times 2. Okay, whereas 124 divided by 2 would be 62, so I can rewrite 124 as 62 times 2. Now, we often skip this step of writing this out, but the reason I do this is to show you why this simplifies. Is when you write it like a product like this, you can see that they have a common factor of 2 here. And if you read this as a fraction, 2 divided by 2, what does that give us? Well, 2 divided by 2 is just 1. So if you actually divide that, that is why those numbers quote unquote cancel out. Is you're dividing them to simplify and you get 34 over 62. That factor quote unquote canceled out because anything divided by itself is equal to 1, which I've written over here. You should get that written yourself. Now, some of you might be thinking, hey, 34 and 62 are both even numbers, so they can be divided by 2 again, right? Or at least I hope you were thinking that. And that's a super important point when working with rational expressions as well, is you want to make sure your fraction gets as simple as possible. So we're going to repeat the process. And I'm not going to write out the steps this time, but we could rewrite it very similarly to what we did before. I'm just going to go ahead and divide it and skip that step because we get the idea now, I hope. So that fraction would be reduced to 17 over 31, which are both prime numbers, so that would be as simple as it can get. Okay, now you could have avoided this by finding the greatest common factor from the beginning, because actually 2 was not the biggest thing that went into 68 and 124. The biggest thing that goes into 68 and 124 actually would have been 2 factors of 2, which would have been 4, and then you could have done this all in just one step. Okay, but if you don't see it, you want to simplify it until it is in its simplest form. The reason I review this is because this is exactly the process you're going to go through when there are fractions. Okay, you're going to try and find greatest common factors and divide them to cancel things out. Okay, so for number 1 is a good example to get us started, because really within number 1 you have a basic numerical fraction, and then you also have those p's, which is where this is different than something you've seen before. Okay, but if I was just to focus on the fraction 16 over 28, okay, we could just divide that by the greatest common factor, which I happen to know off the top of my head is 4. Okay, which would make this 4 over 7 in its simplest form. Now the difference here is we didn't just have 16 and 28, we had p squared. What does p squared mean? P squared is just p times p. And in the denominator, we just had 1p. So really the numerator is 4 times p, and the denominator is 7 times p. Now the reason I expand it this way is because I want to repeat the reasoning we use to simplify integers. Over here, when they have a common factor, like 2 divided by 2 is 1, they cancel out. And note the numerator and denominator over here have a common factor of p. P divided by p is the exact same thing, so that's also equal to 1. So those will also, quote, cancel. Okay, but by canceling, I mean you're actually just dividing them. And when you cancel that factor of p, in the numerator, you just have 4 and 1 p left. In the denominator, there are no more p's, there's just a 7. And you've simplified that rational expression the same way you simplify numbers. Let's look at number 2 to bring up some more examples here. So in number 2, you have 2r minus 4 over r minus 2. And all the time I see algebra students going like, I see a minus 4 over minus 2. 4 divided by 2 is 2. Boom, I can cancel those and make it a 2. You cannot do this. And I'm going to explain why now, but make a note to yourself that you cannot do this. Let's actually write this down off to the side. And I suggest writing this down with like a big cross through it as well, so you remember this for future problems. It's always helpful to think of numbers. So let's say you have the numbers 2 plus 3 over 4 plus 3. Okay, which if you then add those together, 2 plus 3 is 5, 4 plus 3 is 7. That fraction is 5/7. Okay, now what I tried to do here is simplify between the subtraction sign. So let's try to do that same thing here and see if it's equivalent. If I canceled those plus 3's, this fraction would then become 2 over 4. And is 2 over 4 the same thing as 5/7? No, it's not. That's not equivalent. So you cannot cancel between plus or minus signs like here. Okay, the only time you can cancel is, let's say that was 2 times 3 over 4 times 3, which if I multiply those together, it's 6/12. And if I reduce 6/12, that's 1/2. Okay, you divide a common factor of 6 out, which if you cancel these 3's that are being multiplied together, you would get 2/4. And 2/4 is the same as 1/2. So the only time you can cancel factors out is when they're being multiplied. When they're being multiplied, you can cancel. Now the reason for that is because multiplication undoes division, and what you're really doing is 3 divided by 3. That's okay to do. But multiplication and addition do not undo each other, so you cannot cancel here. Don't do it. Make a note to yourself. It's one of the most common mistakes. It has to be a product, aka multiplied, in order to cancel common factors. So going back to number 2, you'll notice there is no product. And way back when, we learned a process to turn a expression into a product. That process is called factoring. So anytime you feel like you can't cancel anything, you have a sum, and you're like, hey, Miss Mancini said you can't cancel things that are a sum, you're going to want to see if you can factor first. Because if you factor, you can turn that thing into a product or a multiplied expression. So in this case, r minus 2 in the denominator is as simple as that gets, but you can factor out a greatest common factor of 2 in the numerator, which is like reverse single distribution. So the numerator is actually equal to 2 times r is going to give me 2r, and 2 times minus 2 is going to give me 4, right? So it's reverse single distribution. If you multiplied that back out, it would be the same thing as the original. So I just factored that by pulling out a greatest common factor, which now this is a product. It says 2 times r minus 2 over, well, this is really 1 times r minus 2. So it's a product like you see down here. And now that it's a product, anytime you have a common factor, you can cancel or divide it. So those r minus 2 are common factors. They cancel out just like the p's canceled out up here, because anything divided by itself is 1. And you're just left with 2 over 1, which we don't even really need that. The whole denominator canceled out. You're just left with 2. I just wrote in the 1 because, that's what's there. If there's nothing else, 2 divided by 1 is just 2. And if you factor, you can simplify this rational expression, because factoring turns an expression into a product. I'm going to write that down. You should too. Product means multiplication. If you don't know that, make sure you write that down as well. turns it into a multiplied thing, which allows us to simplify or cancel. Whatever words you like to use, divide, it all means kind of the same thing. Let's try another one, because as you see here, I have x squared minus 9. They're both quadratics, 2x squared plus 5x minus 3. Again, you cannot cancel the minus 9 and the minus 3 because they're between plus or minus signs. What you can do, though, is you can factor the numerator and denominator and see if there are any common factors that can cancel. So I'm going to pause the video. I want you to factor the numerator and see if you can factor the denominator. I'll give you a hint. It'll look something like this at the end, and I'll come back with the answer. Okay, if done correctly, the numerator is a difference of squares that factors x minus 3x plus 3. The denominator, you just guess and check, and I got 2x minus 1 times x plus 3. Remember to guess and check so you can multiply these by double distributing to see that they're equivalent to the original. If you want to review factoring, please come and talk to me. Otherwise, it's assumed we've already done that. So that's all I'm going to say about that for now. But what this did is it turned it into a product, right? These are being multiplied together here and here. That's multiplication. And since it is, you can divide any common factors, such as x plus 3 over x plus 3, which x plus 3 over x plus 3, anything divided by itself is equal to 1. So that simplifies, cancels out, whatever you want to call it. And all you're left with is x minus 3 over 2x minus 1, which this is as simple as it gets. You do not have to go further. Again, you cannot cancel that 3 and that 1 or anything because it's between subtraction signs. You can't factorize these further, so we would circle that as our final answer. And for this video, that's all we're going to do, and that's how you simplify fractions. Essentially, what you're trying to do is just get them in their most reduced form, just like 68 over 124. If you have any questions, please let me know. Otherwise, I will see you in the next part.